Okay, so here is your introduction into systems of equations. There are three different ways to solve systems of equations. This is a system of equations. System of equations means that you have more than one equation. There are three ways of solving these type of problems depending on how the problem is given to you. Here we're going to discuss the first one, which is graphing. You can solve a system of equations by simply graphing both of the lines. The solution to the system of equations will be wherever the two lines intersect. Okay. Now, your graphs are going to be much better than this. This doesn't have any lines on it, so I'm going to real quick make some lines. Trying to be careful here to make them somewhat perfect here. Okay, so now I'm going to go ahead and graph this line first, starting with the y-intercept and then doing the slope. So the y-intercept is 2, so I'm going to put a dot here at 2. And then the slope is negative 3 over 1, so I'm going to go down 3 over 1. And I can do this a few times, down 3 over 1, just to make sure that I have a straight line. And then I'm going to draw a line through there. Now I'm going to draw the equation for this line. This line has a y-intercept of negative 2 and a slope of negative 1. So I'm going to go down to negative 2. Put a dot, and the slope is negative 1. Meaning you go down 1 over 1, down 1 over 1. I can go backwards to down 1 over 1, go this way, so it looks something like this. I can't do a straight line in here. Hopefully you have a straight edge or something. It's very, very, very important that your lines are straight, because the solution is where the two lines will intersect. If you draw lines that are curved or sloppy lines, your lines are going to intersect at the wrong points. So it's very, very, very important that you draw straight lines. Use a ruler, use your cell phone, use a folder or another piece of paper, but make sure your lines are straight. You can see here now clearly where the lines intersect, and the solution is that coordinate. So the coordinate is 2, 1, 2, 3, 4, 2, negative 4. So the solution to this problem is 2, negative 4. And that's my answer. This is what you would put 2, negative 4. That would be your solution. And that's it. So let's move on down here. So we're going to now go ahead and graph both of those lines, and number one, graph both of those lines and figure out what your solution is. Go ahead and pause the video now. Okay, so I've graphed both of the lines, and you can clearly see where they intersect right here. And so you just write down that coordinate right here. So that's 2, 3. So my solution to this problem would be 2, 3. And it's that simple. You know, sometimes they'll get a little bit more complicated where your lines are something like this, where you have not a y equals line, but an x equals 4. So we can still do this. X equals 4 means that it's going to cross the x-axis at 4. And since there is no y, it will not cross the y-axis. The only way you can draw a line that crosses the x and not the y is to draw one that's vertical. Okay, it's an undefined slope. So vertical at 4, I go 1, 2, 3, 4. And there is where it intersects, and I'm going to draw a vertical line through 4. And now the other one starts at 2, and the slope is down 2 over 1, negative 2, negative 2, negative 2, negative 2. And so you get something that goes like that. So you can see this line here, and those two lines intersect right there, which is 4, 1, 2, 3, 4, 5, 6, 4, negative 6. So the solution is 4, negative 6. That's it. Graph both lines wherever they intersect. That's your solution. Let's move on. Okay. Now go ahead again. Now sometimes the equations will be given to you where it's not in the y equals format. Not in the y equals format. So you're going to have to do a little bit of math. Let me zoom in here so we can do this. You're going to have to do a little bit of math before you can graph. In order to graph, it has to be in the y equals format. So this negative 3x, since I'm solving for y right here, this negative 3x needs to go over here. We do that by adding 3x. Those will cancel. So y equals, always put the x first, so 3x, then minus 7. So that one's set to go. Now we got to do the second one. So let's look at, okay, we're solving for y. Remember, you always move the other one first. Okay, this needs to go over here. Since it's positive, we're going to do subtract 2x minus 2x. That'll cancel. So I'm 2y equals negative 2x plus 10. Then y is still not by itself, so we got to divide by 2, divide by 2, divide by 2. Y is now by itself. Negative 2 over 2 is negative 1, x plus 5. And so now I have the equations in the correct format. So let's zoom back out here. And now I can graph these lines. Let me draw some hash marks here. Your graphs on your homework and quizzes and tests will be like a grid. You won't have to draw your own lines in. That just makes it more difficult. Okay, so the first line, I need to make more of these. 4, 5, 6, 7. And then down here, 5, 6, 7. So the first line right here starts at negative 7, and then so it starts at negative 7 right there, and then the slope is 3, so it's going to go up 1, 2, 3 over 1, up 1, 1, 2, 3 over 1. So it looks something like that. Let's see, I can even go up 3, 1, 2, 3 over 1. The dot would be right there. And now the second line, okay, right here starts at 5 and goes down 1 over 1. So starts at 1, 2, 3, 4, 5, starts somewhere up here, down 1 over 1, oops, down 1 over 1, down 1 over 1, so the line goes something like that. And so you can see where they cross is right there. It's 3, 2. So my solution to this problem is 3, 2. And so that's you know, sometimes you have to change them around like that. But what you're going to find out when we go further is you probably, if the equations are given to you like this and not solved for y, you're not going to graph it anyways. But that's how you would do it. You need to get it in the y equals mx plus b, and then you can graph both lines wherever they cross. That's your solution. That's it. So let's scroll down. Okay, I'm going to have you try numbers 3 and 4 on your own, and then so pause the video and then check back to find the solutions. So here is number 3, and you can clearly see that that is where they intersect. So your solution is 2, -2. All right. Now on to number 4. Okay, so in this particular equation, you see all the work done out. I have, both equations here and both equations graphed. Now here's an issue where our lines look like at some point, these lines somewhere up here will probably intersect. We don't have enough room on here. So this would you'd probably want to solve this a different way. But I want to make sure that you guys are getting the graphing part. Okay, if there was a point at which they intersected, then you would write down that point. There is a point. They will intersect somewhere up here. We just don't have a graph that far. So if you got what I have, then you're good. So we're going to move on to the last piece. Now, what happens once you graph a line and you want to check whether something is a solution or not? Okay, so let's say, up here, let's go back up here. I graphed these 2 lines here. I graphed these 2 lines. Here they are. The point is 2, -2. Okay, how do we check? Is there a way to check and see if I graphed them correctly, if this answer is correct? And the answer is yes. You can actually check your answer. So there's no excuse on why you're getting wrong answers. What you can do is take your point, take the 2 is the x and the -2 is the y, and plug it back into the equation, into both equations, and see if it comes out to be a true statement. So how that looks, if we go back down here now, let's say that this was your intersecting point. This is where they crossed. You can plug the x in, plug the y in, and see if it comes out to a true statement. So I'm going to plug in for the y is 4, so I'm going to go 4 equals 3, and then x is 5 minus 11. Well, 3 times 5 is 15, so 15 minus 11 is 4. Okay, it's true. So this works for this equation. That means that I got the answer correct. So now let's go over to this equation. Okay, same equation, but now we're going to try a different point. You'll see what happens. Okay, so plug in 1 for y and 4 in for x minus 11. 3 times 4 is 12 minus 11 is 1. Okay, so it also is true for that one. I thought I was going to get a wrong answer so I could show you what that looks like, but it looks like it's going to be these ones down here. So again, I'm going to plug in x and y. Y is 4, x is 5, minus 3. 5 minus 3 is 2, and so you'll see here this is not correct. So if you had gotten this answer and plugged it back into your equation and you got a statement that was not true, that means it's wrong. That means that this point is wrong. You graphed something wrong. Something's wrong. This is not the correct answer. Okay, we can look at it over here too. Y is 1, x equals 4, minus 3. 4 minus 3 is 1. So in this case, you have this point is the correct solution to that graph. And that's how you can check your work. So if you're if you're graphing, you can check your solutions and see if you did them correctly. Okay, that is it. That is the lesson. And if you have any questions, send me a message on Canvas or send me an email.